Hello everybody and welcome back. So in this next lesson I'm going to be talking about some basic maths functions, because before we get sort of too involved in all of the fancy and complicated functions that Python offers us, I just want to show you how to do just a little bit of basic Python and things you're going to use all the time, but just standard maths that you can apply within any sort of Python lines, whether you're setting a variable or just wanting to do a quick calculation. So normally we're going to be doing this with floats and integers, but you can add strings together using a plus, but it's not really recommended. It's really bad practice. So let me show you. If you do that, it will add them together, right? These two strings, but there are functions that do this in a much better way and a much more controlled way. You don't want to do this because also, sometimes you're not going to be feeding it just a standard string like this. You'll be feeding it a variable, and if that variable is broken when it tries to add, it's going to error in a way that's a lot harder to account for. Basically, it's just, I would not recommend that you ever do this. I would just use the concatenate function rather. And the format function, there's a lot of better ways to do it, but just know that you can do this. But for example, if we did the same thing with a minus, it doesn't know what to do, right? So you'll see that depending on the data type, which remember in the last lesson we were discussing the data types, depending on the data type, it may or may not know how to perform these basic maths functions. Strings may implicitly know how to be added, but they don't know how to be subtracted or multiplied or divided by one another. Same as with other objects. So you can't really just take one class and add it to another. You can't just take one cup plus another cup and what does that equal? So in classes though, you can actually tell it how to add them, which is something like here in your strings. It has been manually sort of coded into strings that they know how to be added together, but there is no way of subtracting them from one another, right? So we could do the same thing. If we created a cup class, we could say one cup plus another cup equals two cups stacked on top of one another. So we would have to teach it how to add those. But then what's one cup minus a cup? Like how do you do subtraction of two solid objects? Well, you can't really. So it would be kind of the same as the strings. You'd be able to add them but not subtract them. So now don't worry too much about that. We are going to go into more details on classes later, but I just want to sort of refer back to all these data types and show you how they function a little bit differently, right? For example, you can't add modules. You can't take one module divided by another module. There are just groups of functions. How do you do those? So just keep in mind that you cannot use these across all data types, but primarily we're going to be using them on floats and integers. Okay. So you can do some basic, like very, very basic stuff, 2 plus 2, and it's going to spit out 4, okay? So you can give it numbers, or you can give it variables as well. So let's say x equals 3 and y equals 5, and then we can just say, x plus y, right? You can also do x minus y, and it will return that. And obviously if you do it the other way around, you can go x times y, right? So it's just the star is the multiply, right? Because it's not x, right? And then x divide, so just a slash, so x divided by y, or y divided by x. Now I actually want to show you something here. This x divided by y, when I did this, you see how it's returning 0, but really 3 divided by 5 is not 0. But the thing is, these are integers. Okay, so this is actually a very important kind of lesson based on when we're talking about casting different types. Because I've initialized x as an integer and y as an integer, it has returned an integer value. So it's divided x by y, but then has dropped the fraction and has kept just the whole number, okay? And that's not really useful to us. So just be careful of that. So the ways around that is we could cast it, for example. So we could now do our same x divided by y, but we could turn this into a float, right? So we could typecast our numbers, and then we would get a fraction, right? You don't actually even have to do it to the whole number, because as long as at least one of the numbers going into the fraction, well, into the equation is a float, then it will treat all of it like a float, okay? I told you Python does these sort of automatic typecasting, and it does in this case. That's why as long as you've got at least one float, it will convert it. But here, where you're saying x divided by y and you're giving it nothing but integers, it doesn't know that what you really want is a float, okay? So you have to give it at least one, and then it will work, okay? Now another way to do this would be to say that instead of x equals 3, it would be x equals 3.0, okay? If you initialize it like this, then x will be a float, right? Or another way would be, like for example with our y, we can convert it. So we're going to say like this. So here, because y is already set as 5, this y will call that value of 5. It gets converted to a float and then stored in y. So it's essentially overriding itself with a new value, okay? This y will read the old value, and this will set a new value for y. Okay, so now when we return y, it's 5.0 instead of just 5, right? And now here we go, x divided by y and 0.6. Okay, so that's a really good example of why you would sometimes need to actually manually typecast. Okay, so we've got our normal addition, subtraction, multiplication, and division. Another one that we have is power, or exponents, right? So let's just say something like 3 to the power of 2, you know, so 3 squared, right? So that's 3 times 3 is, if you put this to the 2 multiplication signs, right, then whatever comes after that is the exponent. So this is 3 to the power of 2, okay, which is obviously 9, but 3 to the power of 3 is 27, right, because it's 3 times 3 times 3, right? So just 2 multiplication signs will give you power, okay? Then modulus and floor division. We're going to talk about these two because these are actually going to be very useful for many purposes. And if you've never done coding, you might not even know what these do. I mean, I'd never actually even covered these at school or whatever until I actually came to use them in code and had to learn what they were. But now they are very, very handy if you are doing any sort of loops. So now I sort of use this on a daily basis. So don't worry if you don't know what it is, but I am going to explain it. So I'm going to pop open the Python source editor here because I'm going to write a little bit of code in here. Now, the difference between the Python shell and the source editor, the shell is just, it's a console, right? So it's printing. We can type in it, and it's going to immediately, every line we type and we hit enter, it's going to print the result, or it's going to do perform the function that we've given it. With the source editor, it allows us to write multiple lines of code and then hit apply, and it will execute this code, right? If we print in here, it will print to the shell, right? So we can print in here, and then when you hit apply, it's gonna, oh wow, terrible spelling, it's gonna print, okay? And we can actually hit apply multiple times, right? One thing you need to be careful of and aware of is that everything in this gets saved into your HIP file, okay? So if I say accept, it's going to print it, and then I save this scene, and then I open it later. As I open it, it's going to execute the script that's in that. So as I load the scene, it's going to print hello world. Okay, and that can be a problem if you've got some code in here that you've been testing, and then you save it, or you just say accept and you save and close. When you open it later, you're going to run that script again, and it might break things. So be very careful to clear up this, or at least disable everything. So there's this comment out. So if you select everything and you can comment out or comment in, it's just going to add a little hash at the beginning, which turns this into a comment instead of an actual line to run. So then this will do nothing. If I hit apply, nothing happens. Okay. And you can select multiple lines and just use these two over here to comment out or comment back in. Okay. So very useful in that it allows us to run multiple lines. You can run multiple lines in your Python shell, but it is a lot harder. It's harder to understand what's going on until you maybe know the code a lot better. So in the beginning, running a single line or testing a single function is fine in the Python shell. But if you're going to start typing some kind of maybe if statement, so if true, and you see here when I hit enter, it now goes into a different mode with these 3 dots. So it's expecting me to continue typing this line before it executes. So you can type multiple lines, but now you have to know that I need to type something, and then I say, okay, so print hello. And once I'm done typing that function, then when I hit enter, it's going to do it, right? But what if I wanted to go back and alter this now? Now I have to go and do every line again. And once I've entered this line, and then I say, oh no, hang on, I need to change this line. I can't go change this. So it's a lot harder to type multiple lines this way. So I would suggest that you do it in here. You use your Python source editor, you can write multiple lines, hit apply, and then it runs just once. Okay, so I'm going to use this Python source editor to explain modulus and floor division, okay, and also how useful that will be for loops and things later on. So modulus, the sign for modulus is the percent sign. And what modulus is really doing is saying divide one number by another, but then give me only the remainder. Okay. So for example, I'm just going to go back to this shell for now. 10 modulus to 3, okay, is 1. Now why is that 1? Well, 10 divided by 3, okay, is 3 with a remainder. Obviously these are integers again, so if we say 10.0 divided by 3, we'll get this fraction that shows us the remainder. But really modulus is saying, okay, it's 3 with a remainder, so how many is left? 1, okay, because 3 goes into 10 3 times with a remainder of 1, right? Basic maths, I'm sure you remember that. So it returns the remainder only, okay. 10 modulus to, well, actually, sorry, let's go 11 modulus to 3 will be 2, and then 12 modulus to 3 will be 0, okay, because there are no remainders. 3 goes perfectly into 12 4 times, okay. So if we look at what's going to happen over a whole number sequence, we're going to now see how important this is for loops. So here I'm just going to type, now I'm going to show you one little gotcha. That maybe they fixed it now, so, but this is just a bad old habit, but I guess it's safe, rather be safe than sorry. So I always import the Houdini module inside of this Python source editor. Now this module, H-O-U, is the Houdini module. It has all of the functions that we are using within Houdini, like accessing all the nodes and parameters. It should automatically be imported. But the problem is with the Python source editor, if you run a script that causes an error, then it's for some reason seems to drop the Houdini module. And so even if you fix the error and try and run it again, it will then complain that it can't find the module. So my recommendation, and you'll see me do it all the time, is when I start typing in the Python source editor, the first thing I do is import Houdini. Because it doesn't matter if it's already imported, it'll then do nothing. But if it breaks, and then I fix my error and apply again, it will re-import the module, and therefore everything will work. Okay. So as you're typing in here, just straight away start with import who. All right. So, what I'm going to do is I'm going to create a little loop here. Now, don't worry too much about the exact way that I'm writing this. Obviously, if you know some code, you might pick up a few things here, but we are going to go over this much more later. What I just want to do is type a quick thing to illustrate the actual answer, so we can talk about what modulus is really doing. So I'm just going to say for I in range, and I'm just going to pick a range of numbers. So we're going to loop over in the numbers from 1 to 20. Okay. And I'm going to print. So 0 and then modulus to 1 equals 2 format. So we're going to feed it the our number that we want to modulus by. Then we're going to feed it our actual modulus number. So let's say mod equals, so we're going to pick 3 in this case. So we'll give it mod, and then here we'll do I modulus to mod. Okay, so like I said, don't worry too much if you're not really certain about what's happening here. This is just for illustration purposes. So when I hit apply, what it's doing is it's looping 20 times, and it's essentially doing the index number modulus to 3. So it's 0 modulus to 3, 1 modulus to 3, 2 modulus to 3, and so on. And it's printing it in a nice handy statement. Okay, so it's kind of showing us the full equation and result. Now you'll see what's happening here. So 0 modulus to 3 is 0, and 1 modulus to 3, because the thing is 3 goes into 1 0 times with a remainder of 1, right? So it's 1 0 1 2, and then it loops back to 0 because 3 goes into itself perfectly. Then it goes 1 2, and then it goes back to 0, and then 1 2 and back to 0. So you see this pattern: 0 1 2 0 1 2 0 1 2. Okay, so it has 3 indices that it loops between because our modulus is 3. If I go change modulus to 5 and now print, you'll see that we go 0 1 2 3 4, 0 1 2 3 4, 0 1 2 3 4. Okay, so this is why modulus is so useful, is we can essentially pick a number to then loop between. So even though we have a steadily increasing number sequence, and this could go up to as many as we want, you know, this could go up to 50 or 50 million if we wanted to, but our result is going to keep looping between a certain number, right? Very, very useful for many functions that we want to do in Houdini. So now we're going to talk about another sort of similar one that's also going to be equally useful, which is, okay, let me change this back to 20 so it's a little more manageable, is floor division. So floor division, I'll show you on the left here. Floor division, it uses the 2 division. So the same way that exponent was 2 multiplication signs, here we're using 2 slashes for floor division, right? So if we say 10 divided by 3, right? What this is doing is basically it's dividing by 3 and then dropping the remainder, basically dropping any fraction. Okay, so even if we give it a float, it's still going to drop that remainder, right? Now if we go through here, and let me just change up our code. So we're just going to change the function to be floor division instead of modulus, right? And then I print. Okay, it's printed on this side now. what you're going to see is it's going to give us 0, 0, 0, 0, 0, and then 1, 1, 1, 1, 1, and then 2, 2, 2, and 3, right? So it's giving us this many of that same number in a row before it changes, okay? So it's kind of stepping. So if we want some kind of stepping effect, we could actually, you know, feed it this number, and then we can control the size of the stepping here. So we could say, let's just increase our range, and we increase our mod to 5. So then when it prints, our mod is 10. You'll see it's going to print 10 zeros in a row, then 10 ones in a row, then 10 twos, and so on. It's going to step like this. Okay. So very, very useful functions, and you'll see, you know, you're going to use it a lot. Eventually, once you understand it, you're going to use it every day. Okay. So I just want to show another example here while we're going, just that you know that basic BODMAS, I don't know if you guys called it that at school, but we did BODMAS like that, as in brackets, and then of, and then division, multiplication, addition, subtraction, like in that order, right? So that was the order that things happen, you know, functions happen, even if you feed them in one line. So here, 2 plus 5 multiplied by 3, right? So what is that going to give us, right? So that returns 17. But that's not really what I was expecting, because what I'm saying is 2 plus 5 times 3, right? So that's 7 multiplied by 3 is 21. But why did it give us 17? Well, it gave us 17 because it did this first. Okay? And it did that first because it uses brackets, then it uses of, then it uses divide and multiply, then it adds things, then it subtracts. So the multiplication happened first. Okay? So it does actually apply this rule, right? Which means if you wanted it to do the addition first, you need to use something that has a higher value in the hierarchy. So the brackets, for example. So you can go and insert some brackets around the 2 plus 5, and now we'll get 21 if that was the result we were after. So be very careful about the order of your operations. Okay. And now finally, I want to just talk about assignment. So if we go and set a variable, so we say x is equal to 2, okay? So that's just very, very simple. We just say x equals 2 and we hit enter, and now x is equal to 2, okay? But instead of an equal sign, we can also use some kind of mathematical setting functions, right? So if we say x and then we say plus equals 2, what this is going to do is take the value that x currently is and add 2 to it, and then set it as the new value. Okay, so if I say x plus equals 2 and now I print x is 4 because it used to be 2, so now it added 2 and set that as the new value, right? What it essentially is doing, the longer way of writing this would be x equals x plus 2. And this is like before when we were converting to the float. We're calling the old value, we're adding 2 to it, and then we're setting that as the new value, right? So now x should be equal to 6. Okay, so it's just a lot easier to type plus equals 2, and then it's there, so x is equal to 8 now, right? And we can do the same thing with basically every function that we just covered. So we can minus equal 5, and now x will equal 3, okay? We can do multiplication as well, so x times equals 2, which will give us 6. We can do divide equals, so divide equals 2 will give us back to 3 again, because it was 6, so now 6 divided by 2 is 3. And we can even do our modulus and exponent and floor division, all of those. So we say x times equals, and let's say 3. So this will be the equivalent of saying x raised to the power of 3, and then setting that as a new number. So we say x, see there, 27, because 3 to the power of 3 is 27, right? Sorry, excuse me. All right. So let's just go through and finish these all. So you can do divide equals. So that's going to give a floor division of 3. Okay. So now x is equal to 9. And then we can also do modulus as well. So let's just say x modulus equals to 2. And so x will equal 1. Right. Okay. So that about covers the basic mathematic functions. These are not proper functions where you have to actually run, a function with the brackets and then feed it arguments or whatever. These are just standard kind of operations that can be applied within Python. Okay. And like I said, please be very careful. You can do this with integers and floats. Technically, you can add strings together, but you shouldn't. But other than that, with other classes, you need to find out whether a class or not can be correctly added together. Okay, so but we will go into detail about that later. It's actually quite fun to code the magic methods where you teach each thing how to be added together. So you can say, okay, well, one human plus another human, what does that equal? Well, it equals another very small human. But you know what I mean? Like you have to actually, if you're going to code and create a class for a human, then you need to actually teach it how to be added or how to be multiplied. What if we say one human modulus to another human? Well, that's a very bizarre equation, and it may make no sense in terms of humans, but it may make sense in another class. Okay. So, hope this was very useful to you, and I look forward to seeing you guys in the next lesson.